Everybody, we have an interesting problem that deals with onto functions. So let's write down what we mean by an onto function. Y'all, this stands for all r. We'll use little r and then capital R to denote the set of real numbers. So this reads from left to right: for all r a member of the real numbers. Okay. There exists, this backwards E is the existential quantifier, I guess. There exists an A, which is also a member of R. Okay, and let me abbreviate such that was with S dot T dot. Okay. And we're going to write down f at A equals to R. And this literally is the definition of what we mean by an onto function. You know, that's my poor representation of an A. So f at A equals to R. All right. Now this interesting JEE question comes from the Black Book. And the way it's worded is slightly confusing, but it says find the complete set of values of A such that f of x is onto. Okay, so A is kind of like a parameter here. Notice that both of these are in quadratic form, which turns out to be very, very useful. Now let's go down here. So just like I said, suppose f of x is equal to R. So this is saying suppose there is an x such that f of x is equal to R, and this is R is unqualified. So you see this is essentially the same thing as the definition of onto up here. All right, so now notice that what we do, we just literally follow along. We set R equal to the expression. After you do a little bit of algebra, you end up with this quadratic form right here. Okay, you end up with this quadratic form. Now that's key, because this form, this left-hand side of this equation, has a parabolic graph. Okay, now we can learn a lot from that, because you know that the graph is either going to look something like this. It's going to open down. Going to open down, right? And that would happen if 1 minus r was negative. Okay, if 1 minus r is less than 0, this would be for 1 minus r less than 0. Right, so it's going to open down, meaning that you're going to be missing some values of r above here. For example, you would have this horizontal line. Let me just go ahead and denote that by just like this. So we have a horizontal line that misses the graph, right? So that would be an r that wasn't in the range of the function. All right. Now in a similar fashion, if 1 minus r is greater than 0, we're going to have a graph that opens up. Okay, we'll have a graph that looks, you know, wherever it could be located anywhere. You could find the vertex and all that if you wanted to, but let's say it might look like this. And again, you see you're going to have a horizontal line right underneath it, right? Horizontal line right underneath it that misses the graph. Okay, so from the graph, we know that the function cannot be onto, just from the graph. And the graph is the function, and we know that these are very well known. This is a well-known mathematical object. So again, this is not onto because you would miss this value of r. If you want to call this, you would miss this value, and you would miss all the values underneath over here, right? All right, so in other words, it's not, this cannot be, it's not onto. Not onto just from the graph. Okay, and so what we know, what we've learned, is that this set is empty. The set of values is empty. In other words, it's impossible. Set is empty, folks, and that would be the answer to this question. In plain English, it's impossible. But the way the question is worded, you're supposed to, it says find the complete set of values of A such that f of x is onto. Well, again, from the graph, it's clear. Once you do this work here, you get something that's it's in the form of a parabola. The left-hand side of the left-hand side of this equation is in the form of a parabola. And so there's clearly an infinite number of values to where the function itself is not onto. Any r that's above here or below, that's above this vertex or below this vertex, violates the onto-ness of the original. Okay, so I hope that was satisfying. Some people don't think graphs prove anything, but the graphs of parabolas, I mean, the graph of a quadratic is so well known that I think it's a viable option as far as the proof goes. Hope you enjoyed.